This is the foundation inspection. We're at the rear left elevation. Now, I'm giving my elevations based on the road, so I always face the building with my back to the road serving the building. The grade comes too high on the foundation here. It's not an uncommon thing for it to happen, but the problem when you have grade as high as this, it allows moisture, splashback to get onto the actual fabric of the building, the wood, and although logs are pretty impenetrable once they're all sealed and everything, you still don't want to get a lot of water on them. Now we're at the right elevation. We have some penetrations here and a little bit of weather damage coming on here. That needs to be addressed pretty quickly. Cut out, rebuild, or sealed, and then it will stop it. But left like that, it's just going to continue to rot. Here we are at the right near the corner. We have rot here in the actual log. What should happen is that this log is removed in this area around here, and then the wood replaced. Because left as it is, you're not going to stop it rotting. It will continue, and it will spread to other members of the wall. Yes, we have rot here too. That's right on the corner. We're at the right elevation now, looking at the condition of the walls this side of the building. Again, the grade is too high. It was very easy to fix. We'll talk about that when we talk about grading. And now we're at the front elevation. We have a deck, so we can't observe the foundation clearly. We're at the rear elevation. It needs to be regraded here. We've got predominant slope going straight into the building, and that's why we're getting rot along the bottom log of the wall. What I would recommend is the regrading of the area so it slopes down predominantly into a swale or a drain. A French drain would do, but what you want to do is just remove the soil levels down about 4 or 5 inches, so we've got a nice gap between the grade and the wall itself, and that will greatly improve the condition of the walls in the future. We move to the right elevation. All you need to do here is just lower the grade. It slopes nicely, and lowering it will fix that problem. The grade at the front of the house is better seen not right at the front, but from this angle here, and it slopes nicely here. It's all underneath the deck. It's a roof inspection. It's a metal roof. Now, despite all the talks of the contrary, they can leak. And the main cause of leaking is people walking on them. I think, oh, it's metal. What's wrong with walking on that? Well, actually what it does is it moves the panels around the rubber bush here, and that deteriorates and then it allows water in. So resist the temptation to go walking on roofs. We're going to move around and do all of our inspection from the ladder, looking at the roof itself. I'm at the right elevation. Bit of damage to the roof here, it's buckled. Probably flying debris hit the roof. Penetrations up there have been recently replaced. And you can see they're corked around the top. And it's probably a good thing to recork those every couple of years. We're actually in the attic. It's a welded steel construction. Now I recommend that the insulation which we see here, okay, it's a block insulation, it's an epoxy resin and it outgasses. So sometime plan to replace it. Because it's in the attic and it is very well ventilated, I'm not too concerned about it, but it is well worth considering replacing that. We have the air conditioning units here, the ducting. You could see that the ducting actually lays on the floor. Now the problem with that is it can transmit noise into the house. So we tend to suspend them. And that again can be done sometime in the future. You only have to lift them up an inch or two, just so they don't rest on anything where a vibration can pass through. This is the flue. It's all in good condition. No signs of water penetration. This is the plenum, and the plenum rests on top of the air conditioning equipment that's below. And while I'm up it, I'll explain a bit more about the vents. This is the bathroom vent here, and here it's a one-way valve. Very common in metal buildings. It's a good idea, no penetration. But this vent is also a stack serving two bathrooms, or the same bathroom, two parts. One problem: this vent stack is over 5 foot from that, and that means it's over 5 foot or more from the P-track. So an additional vent stack should be added here. You don't have to go all the way up to the roof here, it can be a few foot, but another vent stack put in here, taken up to the roof, would improve the effect of vent stack on the front system, basically to stop it sucking water out. This is the deck. We have portable water here, drinking water attached to the house's drinking supply, and we have groundwater runoff, and we also do not have an anti-siphon device on the faucet. As a consequence, the drinking water can be contaminated with the groundwater. See, it's dripping here. It's been doing this for a long while, and nobody's really taken any notice of it. The solution is to take this union off here, this elbow, and to mount the faucet, the hose bib, directly here. It'll be out of the way of that flow of water. Service panel, you can see here we've got a shelving unit that's been built across the top of the panel, and there are screws in here. Well, I'm assuming there's screws in here because I couldn't get this panel off. I just unscrewed it, but it wouldn't come away. The only way to do that would be to take this shelving unit down. Electrical service panels should never have anything built over them like this, but you know, these are closets and people use them as closets and they want shelves, and that's what happens. I recommend that you modify this shelving unit, which you can, to allow you to get at these screws here and allow that panel to come out. You could easily cut around here and around here, and that gap would allow this panel room to be manoeuvred out of place so you can inspect internally. So I wasn't able to inspect the inside of the service panel. I can tell you from the outside though, that we have a panel of its age. It doesn't have any electrical arc fault detectors, which is to be expected. We have a 200 amp supply, and we have trip ties on the 240 volt breakers, which is correct. And we have a flexible cable passing through the cabinetry. Still. The water heater is incorrectly installed. This leg here, these legs, they need to be held in with metal screws, and so should the flue to the vent hood. There's insufficient combustion air. We have a small vent here. There should be another vent up in the ceiling, and there should be additional vents to provide combustion air for the furnace. This is the compressor unit. No apparent damage to the fins. The insulation. Yeah, I'd replace the insulation on the compressor unit. It's wearing, but it's not the worst I've seen. But yeah, that could do with being replaced. The doors to the water heater and the furnace closet should have fire seals on them, weather seals, around the hole of the door. It's a water meter. It's located at the front elevation of the road. Here's the post box. Here's the water heater. It's under a cover, but the water heater is buried, and that may not bode well for the isolation valve. It needs to be dug out. We're in the attic of the garage. There's packing foam used as insulation. It's not really any good. It takes on moisture and deteriorates. Actually, if you put it in water, it'll just melt, dissolves. Okay, we need to get some caulking around here. Caulking around here. And the drain is broken, so it hasn't got a stop in it. Burners are on, you can see they're heating up. Okay, there are no extractors in the two bathrooms. We're at the dock. I'm not going to run the machinery because it's got a couple of issues with it which need to be fixed out. Here you've got a termination, 120 volts I'd say, and it's exposed to the elements that really should be inside a box.